Welcome to another data science deep dive on our technical track. In the following session, Christopher Gutierrez, Chief Data Scientist at OfferUp, shares that most of the work of scaling data science exists outside the data science team. The setup of image models, NLP, fraud leading scoring, or other models should make deployment by data science simple. Engineering teams, not data scientists, can handle the scaling of the services. Innovations and iterations should happen as quickly as the data scientists can train their models. Enjoy.
Hi, my presentation is on image, text, and personalization models delivered at scale with rapid deployment and iteration. My name is Christopher Gutierrez. I'm the Director of Data Science and Engineering at OfferUp. I've been there for a couple of years. Before going to OfferUp, I've worked at a few large companies that you've probably heard of, and I've also worked at a lot of startups that you probably haven't heard of. I've worked at a couple of startups that are well known and are no longer startups, one of them being Airbnb and one of them being LinkedIn. I'll talk briefly about Airbnb. When I was at Airbnb, it was roughly 200-ish people. LinkedIn, I was roughly 500-ish. So at Airbnb, though, I was among the first managers, and I directly managed their fraud, product analytics, their dashboarding system, and their A/B testing. And I partnered with their data infrastructure group to build their A/B testing infrastructure and their CI/CD pipeline for model deployment. At OfferUp, a lot of my tasks are similar. There's one big difference, though, is that now I directly manage the data infrastructure, which means that I also work on building the infrastructure for A/B testing and building the CI/CD pipelines. So I manage those directly, and that's actually very important, and I'll get to that later. Backing up, though, about OfferUp. So what is OfferUp? OfferUp is the simplest, most trusted way to buy and sell locally. I like to think of OfferUp as a mobile-first version of Craigslist on steroids. So it's similar. It's a buying and selling market, and talk a little bit more about that. So you can sell anything you want, and actually, cars are a big product on our platform. You can post anything. And then on the other side of it, you can buy almost anything somebody's selling. And we also have merchants and stuff, so you can buy stuff from them. But and most of what we'll talk about here is related to our C2C market. So you could buy someone's used camera, like I said, a car, mugs, sofas, whatever you want. You can pick up or have them shipped. Before you purchase, you can look at someone's profile and see their history. You can see if they're trusted or not. And obviously, you can correspond with them. So you can find out, is it available? Should we meet? Where do we meet? So you can ask questions about the item. And so to illustrate how the data science part fits in, we fit in a lot of areas. We fit into search and the posting flow and just basically all over the product. But I'm going to walk through just one piece, the posting flow, just because that covers a lot of our infrastructure. And so I can talk to those points through there. So the posting flow is what you would go through if you're going to post an item. So obviously the first thing you're going to do when you post an item is take a picture. So imagine that you have this picture. So from this picture, what can we tell? We can tell probably that it's a phone. If the model's a little bit better, we can tell it's black. But if it's better, we can tell that it's a Samsung. Maybe we can read it, or maybe we can tell from the logo, or maybe we just know that it looks unique. We could probably, if it's really good, by the camera, by the little cameras on the back, by how they're laid out, we could tell it's a Note 10. So depending on how much time you want to invest, and obviously you invest more in items that show up more often, you can get more detailed on what you can tell. Now, there are things that users must provide, for example, like the condition. From the pictures, maybe you could tell if it was messed up, but you might not be able to tell it was in water or something like that. So The users do provide information like condition, and you can't tell from pictures if it's 5G or not. So that would also be something a user has to provide. Oh, but if we have all of this information already on the top known, that it's a Samsung Galaxy 10, for example, we can ask the right questions. So even if we don't have the answers, we know the questions to ask. What's going to be important? And one of the reasons that we would ask very pointed questions is because if we get enough information, we can get down to the SKU level. So if we know that it's a 5G Samsung Galaxy Note 10, we know a lot more information just by looking up the SKU information. Now that helps us on the posting, but all that information also helps on the search side. So with all of this data available, the user could be looking up, I don't know, Android 9 or something, and this would still come up where it'd be nothing that the user actually entered. Another thing we can do is personalization. So on the personalization side, geo is a form of personalization where you live is unique, but there's also do I prefer shipping or do I prefer picking up items locally? Like for example, I prefer things shipped. My wife likes to pick them up. Do you like merchants or private dealers? I.e., do you like B2C or C2C better? Do you never click on ads or do you often click on ads? All of these preferences we can pick up and customize it. And so now I'll walk through the process of how this works. So there's two different, I guess, main themes. There's batch models and then there's endpoint models. So we'll start with the batch. On the batch models, basically we have a long, obviously pipeline, like sure everybody does, of getting the data ultimately into the warehouse. We focus in mainly here. We have, you'll notice that there's two databases. There is actually, there's BigQuery and there's Presto SQL. So BigQuery, Presto SQL essentially sits on top and above BigQuery. So it's a federated database, and it can also read ORC files, and it can also read other relational databases. BigQuery can do the same thing. So it can also read from ORC files, but the main reason we use Presto, I'll get to. There's a couple of reasons. One of them too, and it's not part of this discussion though, but is that it's multi-cloud. So we can also run a Presto instance on AWS, which you can't do with BigQuery, obviously. So about a reason that we like Presto SQL as well is that Presto SQL allows you to run Java UDFs. And so what we're able to do is essentially, if you use H2O, H2O can write, if you build a model in H2O, you can export it as a Pojo or a Mojo file. Those can in turn be compiled into a Java file. You can also, so those could be converted into a Java file, which you can then have Presto DB use as a UDF. If you do not want to use H2O, you want to use something else, there's open scoring. And I use this at Airbnb. So open scoring, it takes in PMML, and then it also can export Java. Now the PML, how you create that, you can create that in a number of different ways. It reads data from, or actually Python can generate PML. So if you build some models in Python, there are ways you can generate the PMML. If you create models in R, you can generate PMML. It even works in SAS and many other things. It's been around for more than a decade, I think 2 maybe. So it's been around for a long time. It doesn't get used a lot, but a lot of things still support it. So you can easily, one way or another, without having, that's the key, without having data scientists write a line of Java code, you can get Java code delivered, compiled, and then once it's compiled, it can be run in batch as a UDF in Presto. Now, endpoints are the other one, and this is probably the bulk of our models. Now, this is like an overview of what our flow looks like. So First, there's the data prep part, which this is data prep is, when I say data prep, there's data prep and there's the product data prep for Google. What it actually is trifecta under the hood. That's how we manage some data flows, getting it in. Then we have obviously and I'll go into more of these in detail. Then there's the part where we do the modeling. There's the where we put it into Git, the CI/CD pipeline, the endpoints themselves. Then we monitor them when they're in production, and finally we assess, reassess, evaluate, and then build another one. So walking through these one at a time, as I had said, our data prep step is what's interesting about it is if you use Google's data prep / trifecta, it's very it's GUI driven, which I generally I'm not a huge fan of, but in this case it actually works extremely well. I was able to load in a file that was actually comma separated Java or JSON blobs. So you have you have ints and characters, and then there's a JSON blob, and then comma ints, comma character, comma another JSON blob. So there was a lot of JSON blobs in it, and it was able to correctly bring up all of the ints and the characters, parse the JSON into its elements, and it would break the records down if it was an array. So it was able to handle all of that and load that data. So it's impressive what you can do with it. It also identifies if columns are all blank or columns have all the same value. So it's actually a pretty useful tool. And then we have basically the model training. So as I said, there's PrestoDB for some of the model deployments. We use TensorFlow to build our models, and we use BigQuery. BigQuery also has some built-in modeling capabilities. And one thing which I'll talk about more in depth later is the TPUs. So that is kind of a thing that Google has that nobody else has. And then, of course, we have GitHub. So the process to put something into production always goes through Git. It doesn't go directly data scientists setting up anything. So they need to commit things, pull requests managed, and then it goes into our production. Well, it goes into our staging area where it gets tested. We have unit tests, integration tests, testing it against old versions of models, because you would expect if it's a new iteration on an old model, there's going to be you probably expect in most cases like it's going to be a few percent different, and you can validate that in a testing process before it goes into production. Finally, it would go into production, and that's where we typically go with endpoints. So everything we're doing here is going to be in Kubernetes. So it's going to be a Docker container. So you can put the Docker container up as an endpoint, and then other systems can call it. Or you can, and there are other ways you can work with the Kubernetes, which I'll also talk about later. Then there's how we monitor it. So, pre-creating all the graphs, the A/B testing, all of that. And then there's the spot where we kind of start over again. So our technical infrastructure, like I said, we're using Kubernetes. Most of our data stuff is on Google Cloud, but we do have stuff on AWS that we have workflows to get it into GCP. So like I said, the endpoints are actually very interesting. There is a model to where, if you imagine your user is on the phone, it hits a load balancer, it's a service that another team owns. It's trying to serve up, something from the posting flow or search or whatever it is. They need a model, so then they call at the very end the model that they want, and that service calls another model. Who knows? And they're kind of putting it together and sending it back to the user's phone. Because we're using Kubernetes and containers, they can also, instead of us bringing up an endpoint and them calling an endpoint, if you want to bring down latency, or if it makes some other things simpler, they can actually just pull in our container from the repo and make it a sidecar or something else that's part of their service. So And if we make changes, then when they're ready to redeploy their service, they could pull the latest repo, and then they would unit test it again, and integrate test it, and then make sure that everything's okay before they deploy it. So we can actually have the models be inside of their service. Now, the most extreme thing, which we're not doing yet, is you can actually use TensorFlow Lite and build models that go directly inside the client. The obvious drawback is that it's not as powerful, but depending on what you're doing, it may be powerful enough. And obviously, the latency is next to nothing, and you don't have to transfer data, and you don't have to handle the user's data. So that could be a good use case for some PII type stuff. The downside too, in our users are typically not on the cutting edge of new technology and having new phones. So a significant portion of our user base at this moment wouldn't be able to take advantage of it, but that's rapidly changing. And now going on to some more about Google Cloud. And so Google Cloud has a lot of different services, as does AWS and Azure. I'll focus in on just a few that have to do with specifically with data and data science. First, there's like as I said, they have their own container registry and GPU, as do most cloud providers. They have a lot of APIs. They have Cloud Vision. They're basically pre-built models. So they have them for natural language processing and image. And what's nice about that is you can use theirs directly, and it will, it's not that expensive. So if your volume is not high, that may be a route you want to go rather than even build your own models. Alternatively, you can use their models to train your data and then train your own model. So there's a number of ways that you can, piggyback on top of Google's modeling. As I said before, there's Cloud Data Prep. There's Fusion and Composer. So Data Prep I talked about. Fusion and Composer are ways basically to scoot data around. Depending on the tool, there's different levels of, gooiness to it. And I said I'm not a fan in general of GUIs, but it does lower the bar to entry, and so it makes it easier for non-engineers to do some basic data migration. Data Studio, that's another one that we use Tableau for our reporting, but those reports are on fully modeled data. Data Studio is built like right on top. It's a Google product, and you can easily make really simple reports very quickly that work against BigQuery. And it's so quick and easy. A lot of times we'll use that for our ones that are not meant for kind of end consumers. It's kind of it fills a gap between something like a Datadog and something like a full-fledged report. And then finally, there's BigQuery, which I've talked about before. Another thing to note about BigQuery is that it's built because Google built it and Google built TensorFlow, they work really well together, and there's a lot of efficiencies that you can get by calling BigQuery from whatever you're using to code your TensorFlow. And finally, there's TPUs. TPUs is really the biggest game changer in terms of going to Google Cloud. It's something that no other cloud provider has. I can't remember the name of Amazon's their own CPU, but theirs is not for training. That one's for inference, so it speeds up on the other side once it's trained. But the TPUs are great for training data, So to give you an idea, it took us 48 hours to do the specific image classification model that when we moved it, that was using GPUs on Amazon. And then we moved them to GPUs on Google, got roughly the same result as you'd expect. But when we switched to TPUs, it was 30 minutes. So we went from 48 hours to 30 minutes just by switching to TPUs. So obviously that allows us to iterate more quickly. And another benefit is it's much cheaper. because obviously we're only paying, for 30 minutes versus 2 days. But we also are able, because it only takes 30 minutes, we can use preemptible machines. So that's like Amazon's version of a spot instance. So if it, by being able to sacrifice that, hey, if this thing were to go away, all of a sudden I'm okay. And if it's a model that runs in 30 minutes, I'm okay. If they take it away after 15 minutes, whatever, we'll run another one. Uh, on the other hand, if it's 48 hours and it's the 47th hour, you do not want that box taken away. So it's allowed us to bring down costs that way. So we are literally able to build models for pennies on the dollar for what we were before. And so not only do we spend much less, but we don't have to wait as long to see the results, which means we can iterate many, many more times. So in the same, within a week, rather than 2 iterations, we could do dozens of iterations. And a lot of this is related to the organizational structure, particularly on getting these things to scale. And what I mean by that is, most people manage data scientists or data science teams. They manage the data science aspect and the business intelligence that sometimes comes. Rarely, but sometimes you get the data warehouse, and more rarely you get the data platform. In my case, the reason, like the warehouse, when I started, they had Snowflake and Airflow. Now we moved to Snowflake with BigQuery and with Presto, with data lakes, ORC files. The decision unrelated to data science was to move to Firebase, and Firebase was bought by Google, so their data, without having to write an ETL, automatically goes straight into BigQuery, which is great. And eventually, because there wasn't a need to have both Snowflake and BigQuery, we dropped Snowflake. So what that means is that those raw ORC files that were on S3 or on Google Cloud Storage, since Presto can read directly out of them and out of Google, much of our ETL, even if it's from raw files into tables, can be done in SQL, which means that, and in SQL, we can basically orchestrate entire workflows with dbt. And if you're not familiar with dbt, it's a simpler than Airflow. It's basically you can create a DAG with like Ginger code to get your references, and you can create a whole like flow of tables, creating other tables and joining with other tables to create more tables. So you can create your own DAG of 100% SQL. And then you would use just Airflow as a scheduler. Also, there's you can do with SQL. You can make your Tableau reports. And the reason I point this out, and I'm talking about the infrastructure, is because we can do all of this in SQL. It's moved our BI team. They're not just building Tableau. They're actually building work streams and stuff that was previously done maybe prior to it hitting the database. They are able to do. So if something is sitting in an ORC file, rather than have an engineer parse and change it whenever that source file maybe needs to change, the business intelligence people, they can manage that. We've also moved the A/B testing that exists with business intelligence. So this team is highly leveraged. They also build the training data for the data scientists. So the data scientists may be just doing ad hocing stuff to get together to build their first trained model. But once they've already trained it and have determined that these are the variables I need, here's how they go, they'll take that ad hoc query, turn it into a productionized job, and then rebuild it whenever it's needed. And so our data science teams, as I said, there's obviously ROI components that we'll work on. There's retention, there's lead scoring, there's fraud. We have our image detection, and we have our NLP as well. And so for the platform team, this is the one that I was talking about that does our infrastructure. Prior to, or with that team, they basically sat between our data scientists and our other engineering teams. So whether it's like our team that builds our search, or it's the team that works on implementing the blocking for fraud, or it's the team that works on our posting flow. All those teams need models, and they would talk with the platform team and the data scientist rather than just going directly to the data scientist. Prior to having the platform team in the middle, a service would go directly to a data scientist, and often there was miscommunication because the data scientists are not engineers. So there would be a lot of miscommunication, and also a different, because they are not engineers. One team may want one model, and then they need to build all the infrastructure to support that model. A different team may need a different model, and the data scientist doesn't realize that it's really the same flow. It's the same basic design in order to implement. So you would have different teams kind of reinventing the wheel every time they dealt with data science. When we put the platform team in the middle, however, the platform team is able to see that when someone goes to ask what exactly they need, and they're able to deliver that. And when multiple teams come and they all have something that's similar, the platform team can build that one service that supports all the other teams. So the platform team is really at the center of, from the organization's perspective outside the data teams, they're really at the center. They're the front person that everyone goes through to reach the other teams. And one other comment back on that was that it's the one potential drawback that you need to guard against if you have the platform team at the center of many services, it becomes a single point of failure. So this team really needs to be staffed well, and obviously they have on-call. But if you staff them well, then like before I got here, we used to have data scientists and other teams on call. So that is no longer needed. So if you staff this team up correctly, there won't be a problem, and they'll help make the organization much more efficient, so that you'll be able to deliver your image, text, and personalization models, at scale and iterate quickly. So I hope that was helpful.
That was Christopher Gutierrez, Chief Data Scientist at OfferUp, on making deployment faster and simpler for data scientists. If you'd like to watch more videos like this, you could subscribe to the DSS Insider program, where you can see our complete on-demand video repository from a wide range of topics. Subscribe now, following the link in the video description below. Thanks!